today's lesson, we're going to learn about different types of chemical reactions. There are 5 different types of chemical reactions that I'd like you to learn about. The first is called a synthesis chemical reaction. Then we're going to look at a decomposition, a single replacement, a double replacement, and even a combustion reaction. And as we go through each one, I'm going to show you a demonstration and also show you an analogy to help you learn about this type. The first type of chemical reaction that we're going to look at is called a synthesis reaction. In this type of chemical reaction, we essentially have 2 reactants. Remember, reactants are the chemicals that you're starting off with. So we're going to have 2 chemical reactants. I'll call them A and B. And during this chemical reaction, A and B will merge to make one product. Again, the product is what you end up with in a chemical reaction. So let's use my students as an example. Let's say there's a lovely girl in my chemistry class by the name of Liliana. And Liliana notices a very handsome boy in the same classroom by the name of Anthony. In chemistry class, Liliana and Anthony fall in love and they become one couple. This is a great example of a synthesis reaction because we had 2 things that were separate. They fell in love and became one couple. This is exactly what happens in a synthesis chemical reaction where 2 chemicals merge and make one. The first demonstration that I'm going to show you is for a synthesis chemical reaction. So here I am in the chemical supply room, and in front of me I've got a whole bunch of gas tanks. So specifically what I'm going to try to do is take a balloon and I'm going to fill it with 2 different gases. One of them is oxygen gas and then the other one is hydrogen gas, and then we'll take it into my lab and we're going to do something that's pretty exciting with it. So let's just fill up the balloon with gases right now. That always scares me a little bit. Okay, so what I did was I added a little bit of oxygen, a little bit of hydrogen. I'm going to tie off the balloon as best I can. And then we're going to go do something in the other room. Okay, so we're back in the lab, and as you can tell, I've got some ear protection on. I've got my hydrogen gas and oxygen gas now in the balloon. I'm going to take a lit candle and I'm going to touch the surface of the balloon. Right now the gases inside of there, they're colliding with each other, but the chemical reaction has not begun. We need to give it some extra kinetic energy so that those particles hit each other really hard so that the bonds can break open and new bonds can form. So in a moment, I'm about to turn off the lights, I'm going to light the candle, and we're going to get the chemical reaction going. Is everybody ready? Put your ear protection on. Okay, so hopefully you can see my lit candle. And I'm about to touch the surface of that balloon. Here we go. How about that for a chemical reaction? As for me, I'm glad I was wearing my earmuffs so that did not hurt my ears. Hopefully you enjoyed that synthesis chemical reaction. You might be asking yourself, what was created during that chemical reaction? Well, when the hydrogen and the oxygen gas come together, like we said, 2 elements are going to create one compound. So the hydrogen and the oxygen gas come together and make water vapor. Notice we didn't see liquid water falling out of the balloon. but we were making water vapor because it was at such a high temperature when that explosion went off and so much energy was given off that the water was in a gas form. The second type of chemical reaction that I want to talk to you about is called a decomposition reaction. In a decomposition chemical reaction, we have one reactant. That's the easiest way for you to tell that you're working with a decomposition reaction is because you start off with only one reactant. And during the decomposition, something happens that causes this one reactant to begin to fall apart and create two or more products. For instance, if I had one reactant, let's just call it AB, and it began to decompose, you would end up with two different products, A and B. If I use my students as an example of this, we could start off with our couple that had fell in love, Anthony and Liliana, and this couple, something bad is about to happen. During class, Liliana notices something that really disturbs her. Anthony has a wandering eye, and Anthony's been checking out the other ladies in the classroom. Liliana is not happy about this. She gets very upset with Anthony, and they decide they're going to break up. So, starting off with one reactant, they break up into two separate products. A great example of a decomposition reaction. In our next demonstration, we're going to show you a chemical reaction that's classified as decomposition. So here's what I've got for my reactants. Notice that I've got a large graduated cylinder, and inside the cylinder what I've done is I've put some hydrogen peroxide. Now this is not your everyday, ordinary hydrogen peroxide that you would find in your medicine cabinet at home. That's 3% hydrogen peroxide, meaning the other 97% is actually water. This hydrogen peroxide is 30%, so the concentration is much, much higher. So I've put, anywhere about 50 to 70 milliliters of hydrogen peroxide in my cylinder. Just for fun, I'm going to take some detergent and just add some soap in here just to make this a little bit more interesting. Okay? Now, the hydrogen peroxide that we're putting in as an ingredient, hydrogen peroxide comes in this brown bottle. And you might wonder, why is it in a brown bottle like that? Well, it's very sensitive and it decomposes very easily. So when hydrogen peroxide is exposed to light, the light is enough to cause the hydrogen peroxide to decompose into water and oxygen. So they put it in this brown bottle to prevent the light from getting to the chemical. However, over time, the hydrogen peroxide does decompose anyway. So if you've had hydrogen peroxide in your medicine cabinet for, let's say, a year or two, it's been decomposing over time, so when you go to put it on a cut, you're actually just opening up the cap. The oxygen is being released from the very top of the bottle because it's turned into a gas up there, right? And then what's left on the bottom, the other product of the decomposition is just plain water. So the oxygen would just be released and you're just pouring water on your cut, which is not really going to help you out. So you should always throw away your hydrogen peroxide every 6 months or so and get a new bottle. So let's get going. Here's what we've got. As I mentioned, I put some soap in with my hydrogen peroxide, and I'm going to get the decomposition reaction going very quickly. And so to do that, I'm going to use a catalyst. This is a catalyst called potassium iodide. It's in a solid state, and I'm going to take a scoop of it, and I'm going to just dump it into the graduated cylinder. If I can get some out of here, that's a big chunk. Okay, so let's try this. One of the things that I'd also like to do, just to give you some evidence of a chemical reaction, and I've never tried this before but thought it would be fun to do. If one of our products is oxygen gas, I'm going to do a lit splint test. As you know, oxygen is a reactant that's necessary for burning. So if I bring a lit wooden splint near the oxygen that's being released, my hope is that we're going to see the lit splint get a little bit more fiery as the oxygen helps it burn. We'll see. So let me move some of my chemicals out of the way. Let's throw in our catalyst, and here we go. This is called elephant's toothpaste. And let's see if this really is oxygen. If I tamp it out a little bit, let's see if it helps it burn a little bit more. Not a whole lot of evidence of that. But cool nonetheless. So you'll see that there's a lot of steam being released, and some of the oxygen gas is getting trapped in the detergent. And so as that oxygen gets caught in the bubbles, we have this really cool effect that we think looks like the toothpaste you might use for an elephant, and it just keeps going and going and going. So really what we're making happen is the hydrogen peroxide is decomposing all at one time instead of very slowly over time, and that's the whole point of the catalyst. The third type of chemical reaction that I want to talk to you about today is called a single replacement reaction. In a single replacement reaction, we typically have one element, and it's introduced to a compound. The compound is typically dissolved in water. The element that comes in will kick another element out of the compound. Let's take a look at it with our friends from chemistry class. Previously, we had learned about Anthony and Liliana, and they were a couple that had fallen in love. But we knew that Liliana had become very angry with Anthony because he had a wandering eye. Well, at the time, we had never learned who was Anthony actually checking out in their classroom. Well, now we learn. There was a lovely young woman by the name of Karima in our class, and Anthony decided that Karima was a pretty lovely lady, and they decided that they would become a couple. Of course, notice how Anthony has to shift couples. He was originally with Liliana, and now he's with Karima. So in the beginning, we had one element and one compound. And in the end, we have one element and one compound. Essentially, the ladies have switched places in this analogy. That's a single replacement reaction. In our next demonstration, we're going to do a single replacement chemical reaction. So let's talk about the reactants that we're working with today. Notice in the weigh boat, I have some solid zinc. Okay, and in a moment, we're going to put that solid zinc in a small Erlenmeyer flask. The second reactant that we have is some pretty concentrated hydrochloric acid. This is 6 molar hydrochloric acid, and I'm going to add a little bit of that to the zinc. So that's going to take place in this Erlenmeyer flask. And as this goes on, the zinc and the hydrochloric acid should chemically react with each other. And as we talked about with the Barbies, usually we have one element kick out another element. So in this case, the zinc is going to be able to kick out the hydrogen that's a part of the hydrochloric acid. Well, this is pretty cool because that means the element that's coming out as a product is hydrogen gas. And as we've talked about before, hydrogen gas is flammable. So what I'd like to do to kind of spice this up a little bit is as the hydrogen gas is produced, you'll notice that I've got some tubing. And I'm going to thread the tubing into some soapy water. I just put some Dawn soap in there and added it to water, and I'm hoping I'm going to get some bubbles. And if this really works, then I'm going to light my flammable hydrogen bubbles, and you'll see what happens. So let's get going. So I'm going to take the solid zinc metal, and put it in the Erlenmeyer flask. And now take my bottle of hydrochloric acid and just give enough to get this chemical reaction going. Notice the bubbles immediately. The bubbles are, of course, a sign of gas production, and that is the hydrogen gas that is being produced. We're going to try to thread that into our soapy water and hopefully get some bubbles created that don't just have normal air in there, but actually have hydrogen gas in them. And so as that builds up, watch this carefully. This is pretty fun. Woo! You see that? That's hydrogen gas, and it's igniting as it reacts with the oxygen in the air. So let's let a little bit more build up. And here we go. Woo! And if you go back and you look at the Erlenmeyer flask, look at how vigorously that single replacement reaction is going. Notice how the zinc is basically, it looks like it's being eaten away by that hydrochloric acid, and all those bubbles that you see, that's hydrogen gas that's being created. So the zinc is the element we start with, but the hydrogen is the element that we end up with. So again, let's try to light a little bit of this on fire. We'll do this a few times just because it's so entertaining to me. Woo! That was a loud one, right? And the hydrogen is reacting with the oxygen in the air when I give it that extra energy from the flame, very similar to the balloon that we saw not too long ago. So I'm actually doing a single replacement, but then I'm actually doing a synthesis reaction when I'm combining the hydrogen gas with the oxygen. In the fourth type of chemical reaction that we're going to talk about today, it's called a double replacement. In a double replacement chemical reaction, you typically have two compounds that are dissolved in water. When you add the two compounds together, you typically create two new compounds. One of the two is what we call a precipitate, or an insoluble compound, a compound that does not dissolve in water. When we look at this with our friends, the Barbies, let's see what this looks like. As we learned in a previous demonstration, Anthony and Karima had become quite a couple. They decided they would go to prom together, and they were very happy on the dance floor and having a great time. However, we also knew about Liliana. Well, Liliana was not one to stay at home and be sad. She went out and found herself a new boyfriend. Liliana's new boyfriend is named Colin. And Colin and Liliana also decided that they would go to prom. So on prom night, both couples are on the dance floor and having a great time. But in the middle of a song, a very romantic song, Liliana notices that Anthony is, you know it, checking her out. And the love returns. And so in the middle of prom, here's what happens. Liliana decides that she wants Anthony back. And so they go back to being a couple. But Colin and Karima are there to have a good time. So they're not going to go off on their own and pout. They decide to become a new couple as well. We call this the prom switcheroo. Essentially, the ladies have switched dates. They started off with one man, and by the end of the prom, they're with another man. A great example of a double replacement reaction. In our next chemical reaction, I'm going to show you a demonstration of a double replacement. Here are the chemicals that I'm starting with. So my first reactant is a solid chemical that's called cobalt-2 chloride. If you zoom in and take a look at this, it's a really pretty pink color, but right now it's in the solid state. So I wanted to show you what I'm going to do with this. I'm going to take the solid cobalt chloride, and I have some deionized water, and I'm going to put that in there. And the reason I wanted to show you this is I wanted you to understand that what I'm making is called an aqueous solution. So the solid cobalt chloride is dissolving in water, and we are making a homogeneous mixture, which in chemistry we call a solution. And this is going to be my first reactant, okay? So once I get the cobalt chloride nice and dissolved, which I think it is now, notice that really pretty pink color. Okay, I'm gonna pour it into this nice clear plastic cup so it's really easy for you to see. That's the only reason why I'm using that cup. The second chemical reactant is in this large jug. So this is a chemical that's already pre-made for me. It's a solution that is called sodium silicate. And so in a double replacement reaction, what you typically see is both compounds have been dissolved in water. So we're dealing with two aqueous solutions. Aqueous means water-based, so the chemicals have been dissolved in water. So I'm going to take the second reactant and add it to the first reactant, and notice what happens when the two are combined. So I love the color of this product. This is what we call cobalt blue, and it's got a really beautiful deep blue color to it. And I'm going to take a stirring rod and just stir it up a little bit, and notice the solid that has been created. So one, I like this because I think it's really beautiful, but two, I want you to visually see that a precipitate has been created. Remember what a precipitate is. A precipitate is a solid that forms in a chemical reaction. So we're making something that is not soluble in water anymore. And so what we've got as our products, there's actually two of them. One of them is called cobalt 2 silicate, and that's that really pretty blue chunky solid that you see created in there. And the other one is merely sodium chloride. Now, sodium chloride does dissolve in water. And so that is still floating around in the water that we've got here. But what's most noticeable, of course, is the chunky precipitate that we created, which is insoluble in water. And that is typically what we look for in a double replacement reaction, is when two aqueous solutions are combined, a precipitate is typically created as one of the products of the chemical reaction. In our fifth type of chemical reaction, it's called a combustion reaction. I can't really use the Barbies to exemplify what goes on in this chemical reaction, so let me just explain it ahead of time. In a combustion reaction, we will take a hydrocarbon. Now, a hydrocarbon is an organic compound. It is made of hydrogens and it's made of carbons. This hydrocarbon chemically reacts with oxygen. Oxygen is in the air. So think of it this way. The hydrocarbon is going to be lit on fire. And you know nothing can burn without oxygen. So when the hydrocarbon burns in the oxygen, it always produces the same two compounds, carbon dioxide and water. Both of these products are in the gaseous state. A lot of heat is released in an exothermic reaction, and so we get carbon dioxide gas and water vapor as the products of this chemical reaction. In our next chemical reaction, I'm going to show you a combustion reaction. If you remember, combustion is where you take a hydrocarbon, a compound that is very rich in carbon and hydrogen, and burn it in oxygen just in the air. And we're always going to create carbon dioxide and water vapor. So it's a pretty easy chemical reaction to remember the products of. So here's what we've got. I'm going to turn on my gas valve, which is over here by the wall. And when I do, methane, CH4, is going to bubble through this tubing and into some soapy water that I've got in this little contraption. So the methane should get caught in the bubbles, and then I'm going to try my best to get my hand wet and light the bubbles on fire. So let's see if this works. Okay, so here we go. I'm going to slowly start creating some bubbles. move this around just a little bit to get, here we go. Slow it down a little bit because that looks crazy. Okay, so let's see if I can get my hand extremely wet. Lift off a couple of these bubbles for you. Woo, that's hot. Let's see if we can do that a couple more times.
They're growing.
Okay, here we go. We're going to try it again. Lots of water on my hand. Scoop. And it ignites. So every time we light that on fire, we're getting a very exothermic chemical reaction. A lot of heat is produced, which is why the water's on my hand, kind of a barrier to protect my skin. And we're producing CO2 and H2O. Let's do one more just for fun. Again, I'm going to make sure I've got lots and lots of water on my hand. We're going a little crookedy now. Small scoop. And we've got a combustion reaction. I just want to thank everybody for watching today's video on classifying different types of chemical reactions. My hope is that you can now classify synthesis, decomposition, single replacement, double replacement, and combustion reactions. So from my classroom to yours, I'd like to thank you. And my students, thank you as well. Don't forget to go home and practice chemistry at your own house.